Okay, good morning. Welcome to
SuperMath number 23.
SuperMath23. So we took a break from our geometry review today to talk about an AMC8 problem that gave you a little bit of difficulty about counting. And I thought it was kind of a fun problem, so I made up one that was similar to it. And we're just going to go through that today. Okay? Okay?
Yep.
How many integers from 1 to 999, including 1 and 999, do not have the digit 2 or the digit 7? Okay, you understand the problem?
Yep.
Alright, so our problem, the AMCA problem was only missing 1 digit, so now we're going to be missing 2 digits.
I think I've got a way to approach this.
Okay.
So, I'm going to divide it into cases. This is 1 digit, 2 digits, and 3 digits.
Okay.
So 1 digits, there's 7 choices, because we have 1 through 9, and we're missing 2 and 7.
Okay.
So, there's 7 numbers. For the 2 digits, we have, this is 7, because this one behaves like this one.
Alright.
And this one's 8, because we're missing 2, 7, but we're missing 2 and 7, but we can use 0. We can't use 0 here.
Okay. You can't use 0 as the first digit of a number, but you can use it as a later digit, so you have more choices later on. Okay, good.
So this is 56.
Alright.
Then we have 7, 8, 8. This, because you can use 0 here and here, and you can't there.
Okay.
This is 64 times 7, which is 420 plus 28, which is 448.
Okay.
So now we have to add this up. 448, 56, and 7. Let's see, 490. Then we have 21. 511.
Okay. So, and I want to show you a different way to approach it. Sorry for the smudges, brother, Sylvie. That is the right answer. But does that remind you of any number?
Well, 511, it's close to 512, which is 2 to the 9th.
Okay, 512, write that down here, equals 2 to the 9th. And what's special about 2 to the 9th in terms of this problem is that it's 8 cubed. Or 2 cubed cubed. You see that? Okay. And the 8s, you see some 8s in this problem, but also some 7s, so we've got to figure out what's going on there. But what we can do to do this problem in a slightly different way is pretend all of these numbers from 1 to 999 are 3-digit numbers. You said you couldn't start with a 0. But we actually could if we wanted to. We could easily write the number, I don't know, 54 as 0, 5, 4. Okay. And we would normally say this is a 2-digit number, but it's fine to say it's a 3-digit number that starts with 0 for purposes of counting. Okay. So in fact, we actually do have 8 choices for the first digit, 8 choices for the second digit, and 8 choices for the third digit, because it can be any number from 0 to 9 except 2 and 7. Okay? And we just said that 8 times 8 times 8 is 512.
But we got 511.
Yeah. There's just one little tiny problem.
Well,
we overcounted somehow. Instead of getting 511, we got 512.
I think
and that means
see the little problem.
It means we counted one extra number. And what? Do you see what it was?
0, 0, 0.
That's right. We counted the number 0, 0, 0 because we said I could pick a 0 for the first digit, a 0 for the second digit, and a 0 for the third. So we don't want that number because we said we were going to start at 1. So 511. So it turns out when we were missing one number, we got 728. So the problem on the AMCA said you're going to count these numbers except you don't want the digit 1. We got 728, which is 1 less than 729, and 729 is 9 cubed. When we're missing 2 digits, we get 511, which is 1 less than 8 cubed. if I said we're going to miss 3 digits, what should we get 1 less than?
7 cubed.
Do you happen to know what 7 cubed is?
Is it 243? It's 343.
343.
So 342.
342 numbers would be missing, say, 2, 7, and 5. Pretty neat, actually.
Yep.
Alright, good job. That's good. That's a neat counting problem.